Welcome to my channel. World Scene News. Subscribe to my channel for news updates all around the world. The 9K-33 Osa, known to NATO as the Sa-8 Gecko, is Russia's mobile, short-range air defense workhorse, a system that has become a familiar sight on modern battlefields. Its unique design packs radar, command and missiles all onto a single amphibious vehicle, allowing it to operate across rivers and rough terrain with ease. Introduced in the 1970s, the Osa's all-in-one configuration lets it move seamlessly with advancing ground forces, shielding them from low-flying aircraft, helicopters, and, increasingly, swarms of drones that dominate today's conflicts. The Osa-AKM, a modernized variant introduced in 1980, brought significant upgrades, improved radar, better electronics, and the advanced 9M33M3 missile, now stored in sealed containers for faster, safer reloading under fire. In Ukraine, the Osa-AKM is constantly in action, defending Russian units from relentless Ukrainian drone attacks. It provides both point and area defense for mechanized columns on the move, adapting to the ever-changing threats of modern warfare. Its mobility and independent targeting make it a flexible frontline shield, able to reposition quickly and engage multiple threats. But the high tempo of drone warfare is straining Russia's missile supplies like never before. Each engagement burns through valuable, increasingly scarce missiles, forcing Russia to dig into Cold War-era stockpiles that were never meant for such intense, sustained use. The recent use of older, sometimes unreliable missiles on Osa-AKM systems is a clear sign of a deepening logistical crisis as Russia struggles to keep its air defenses supplied. Russia's frontline air defense now relies on whatever munitions it can find, no matter how outdated, highlighting the immense pressure and uncertainty facing its forces as the war grinds on. Russian Osa-AKM systems have been spotted carrying a mix of modern containerized 9M33M3 missiles and much older, exposed 9M33 missiles, 2 generations behind. These older missiles, lacking protective containers, are less reliable and less effective against agile drone threats. Their reintroduction isn't tactical innovation, it's desperation, as Russia pulls obsolete munitions from storage just to keep launchers operational. The sight of these antiquated missiles on modern vehicles is a stark symbol of Russia's strained logistics. Missile expenditure has outpaced production, and there's no evidence new Osa missiles are being made. Using the 9M33 is a calculated risk, better a weak missile than none at all. This improvisation is part of a wider pattern. Other Russian air defense units, like Buk M3, are also running with fewer missiles. The return of the 9M33 signals a systemic shortage threatening Russia's ability to protect its forces. Russia's use of obsolete 9M33 missiles is driven by a severe shortage of modern munitions, as the war in Ukraine burns through stocks at an unsustainable rate. Pre-war calculations never anticipated this level of attrition, especially with Ukraine's relentless drone tactics. Sanctions have crippled Russia's access to high-tech components, making new missile production nearly impossible. Forced to adapt, Russia is raiding vast Cold War-era stockpiles, including naval Osa-M reserves, to keep air defenses firing. The logic is simple. A less capable missile is better than an empty launcher. This cannibalization is a hallmark of logistical crisis, not innovation. Russia is now relying on museum pieces to sustain its war effort, sacrificing performance and reliability. It's a stopgap that buys time, but at a steep cost to effectiveness. The return of 1970s-era missiles highlights a deeper failure: Russia's inability to sustain high-intensity warfare with modern munitions. This isn't just an Osa problem. Buk M3s and even cruise missile stocks are running low, forcing reliance on older, less accurate models and foreign supplies. The unprecedented scale of drone warfare has forced air defenses to fire almost continuously, depleting finite missile reserves. Western sanctions have cut off access to advanced electronics, halting new missile production. As modern stocks dwindle, Russia turns to outdated alternatives, which are less effective and require more launches per target. This accelerates depletion and exposes Russian troops and logistics to greater risk. Using old missiles is a temporary fix that ultimately worsens the problem. The brittleness of Russia's air defense is now on full display. Each workaround reveals a military stretched to its limits. Mounting old 9M33 missiles on Osa-AKM launchers was a crude but straightforward fix. Salvaged 1970s guide rails were bolted onto modern vehicles. The Osa-AKM's fire control systems retained enough compatibility to guide the older missiles with minimal software tweaks. This field modification is a testament to frontline resourcefulness, but also to a lack of central solutions. Russia's vast inventory of mothballed Soviet gear made this possible, including naval Osa-M stocks. However, exposed missiles are vulnerable to weather and shrapnel, increasing malfunction risks. The performance gap between old missiles and modern launchers means the system can't reach its full potential. It's a compromise, sacrificing reliability and capability for the simple need to keep firing. Desperation, not innovation, drives these adaptations. The battlefield is unforgiving, and Russia's improvised Osa-AKMs are prime targets. On October 29, 2025, Ukrainian drone operators located a camouflaged Russian Osa-AKM and relayed its position for a precision FPV drone strike. The drone slammed into the vehicle, causing a catastrophic explosion that destroyed both the launcher and its missile stock. This strike is part of Ukraine's systematic campaign to degrade Russian air defenses, opening the skies for further attacks. Each destroyed Osa creates a gap in Russia's shield, exposing troops and logistics to greater risk. The supremacy of drones in modern warfare is clear. Mobile air defenses are now highly vulnerable. For every Osa, Russia keeps running. Ukraine is hunting to take it out. The cycle of attrition is relentless, and Ukraine is gaining the upper hand. The loss of another Osa-AKM is just one of at least 32 Osa-type systems Russia has lost since 2022, destroyed, damaged, or captured. These losses are mounting steadily, and each one represents a significant blow to Russia's ability to defend its forces on the ground. The Osa-AKM, once a backbone of Russian tactical air defense, is now becoming a rare sight on the battlefield. Each loss weakens Russia's forward air defense, leaving ground units and supply lines exposed to Ukrainian attacks. Without these systems, Russian troops are far more vulnerable to drone and missile strikes, and Ukrainian forces are able to exploit these gaps with increasing frequency. The Osa is vital for protecting mechanized columns and logistics near the front, but as numbers dwindle, gaps in coverage grow. These gaps force Russian commanders to make difficult choices about where to deploy their remaining assets, often leaving some units dangerously exposed. Ukraine's campaign has also targeted more advanced systems, Buck M3s, S-400s, and long-range radars, systematically dismantling Russia's air defense network. The destruction of these high-value assets further erodes Russia's ability to contest the skies and protect its forces from aerial threats. This forces Russia to pull assets further from the front, reducing their effectiveness and creating safer corridors for Ukrainian strikes. As a result, Ukrainian aircraft and drones can operate with greater freedom, striking targets that were once heavily defended. Every lost Osa is not just a vehicle gone, but a fraying of Russia's entire air defense net. The cumulative effect is a growing sense of vulnerability among Russian troops, who now face the constant threat of attack from above. The cumulative effect: Russia is losing control of the skies above the battlefield. Ukrainian pilots and drone operators are increasingly dictating the tempo of operations, shifting the balance of power. The toll on its SAM systems is a primary reason why. As these losses mount, Russia's ability to defend its troops and territory from air attack continues to erode, changing the dynamics of the conflict. Russia's use of 1970s missiles on 1980s launchers is battlefield improvisation born of scarcity, not progress. In contrast, Ukraine's adaptations have been forward-looking, like modifying Osa launchers to fire modern R-73 air-to-air missiles, a complex technical leap. Ukraine's Frankensam projects integrate Western and domestic tech, giving old platforms new capabilities. These upgrades require significant engineering skill and a problem-solving mindset, making old systems better, not just functional. Russia's fixes are simpler, plugging gaps with whatever is available, even if it's inferior. This isn't a lack of skill, but a sign of a rigid, less innovative system. Russia's approach is regression, Ukraine's is fusion and advancement. This difference in adaptation may shape the long-term outcome of the war. The deployment of obsolete 9M33 missiles on Osa-AKM systems is a stark indicator of Russia's mounting logistical strain and deepening missile shortages. Once considered reliable, these aging weapons now symbolize a desperate attempt to maintain air defenses as modern munitions run low. Relying on outdated technology is a short-term patch that not only reduces operational effectiveness, but also exposes deeper, systemic weaknesses in Russia's ability to sustain high-intensity conflict. The cracks in their supply chains are becoming more visible with every passing week. Each destroyed or downgraded air defense system creates new vulnerabilities for Ukraine to exploit, opening corridors in the sky and on the ground. These losses ripple through to the front, eroding Russian confidence and emboldening Ukrainian tactics. The steady erosion of Russia's air defense network is shifting the balance in the skies, giving Ukrainian drones unprecedented freedom to strike deep behind enemy lines. Each successful drone mission further weakens Russian positions and sows uncertainty among their ranks. While Russia raids its Soviet past for spare parts and outdated missiles, Ukraine fuses cutting-edge Western technology with legacy systems, creating hybrid solutions that enhance their battlefield capability and flexibility. This stark contrast in adaptation highlights Ukraine's resilience and ingenuity, while underscoring Russia's managed decline and growing dependence on relics of a bygone era. The modified Osa-AKM stands as a microcosm of the wider war, marked by attrition, logistical strain, and the critical importance of technological adaptation in modern conflict. As Russia's old stockpiles dwindle and their shield falters, the skies tremble not just with the threat of Russian missiles, but with the relentless advance of Ukrainian drones, exploiting every gap and reshaping the air war's future.